Привет. Gani Punamayo Bruski. And now I've shared everything I know in Russian. Well, spasiba pожалуйста. As Dennis said, my name is Christopher Bennage. Today I'm going to talk to you about CQRS, and I want to start out by confessing that the subtitle here is a little bit of a lie. My talk doesn't really have anything to do with Azure at all. So if you're interested in learning more about Azure, you'll have to go to some other source. My talk is really more about architectural styles and patterns that really can be applied to any applications you're building. They don't even have to be on the cloud. So, I want to start off by saying that the requirements of applications that we are building today have changed. And as a result, the way we build these applications needs to change as well. There are architectural patterns that we have used for decades now to become standard tools in our toolkit. One of those, and I think it's misleading to call these new requirements because in many ways, these are just the logical progressions of the requirements we've had for a long time, well-established requirements. So regarding scale, it's not enough to simply scale out our systems to meet demand. We really need to ensure that we can do this with a predictable cost. Because if a system scales, but it costs us a fortune, it's not really worth doing. And at the same time, we can't predict, as I said a moment ago, when we'll have these surges in demand for the applications. So it has to be elastic. And elasticity is a word that I personally like to use to describe this ability to scale at unpredictable times. I also believe that elasticity implies being able to reduce the cost. Well, that was all I got to do. Too many notes on my slides. I believe that elasticity means that we can also scale down the resources that we're using for our applications in a responsible manner so that we're not paying more for our apps than we need to be paying for them when they're hosted on a third-party service like the cloud. Now, user expectations, as I said, is that applications and services are always available now. Time lost corresponds directly now to money lost. And likewise, the systems we're building today, they're increasingly global. So the old idea, of 10 years ago, where we'll do maintenance in our applications while the users are sleeping, isn't true anymore because we live in a world where our users are everywhere, awake constantly. So we also need to be able to achieve these new requirements while keeping the systems maintainable. And that's really one of the difficult components of doing this because we're talking about increasing the complexity of our systems to handle these requirements, but we want to increase complexity in a way that doesn't make the system more difficult to maintain. We also, at the same time, since we're building these systems that are more sophisticated, there will be failures in the system. So we have to design them in such a way that they are resilient to the failures. So this leads us to this topic of CQRS, or Command Query Responsibility Segregation, which personally I think is a mouthful of words to say. And really what is this? CQRS is an approach or an architectural pattern that can be applied to address some of these requirements. Now, I'm using some intentionally vague language like approach because I think it would be easy to misapply this idea in many ways, and I'll talk more about that. But CQRS simply means that we separate the commands in our system from the queries in our system. By commands, I mean the parts of our system that change or mutate the state. And query means those parts of our system that read that state back to the users and display it. Throughout the talk, I'll sometimes use the terminology read and writes in place of queries and commands. Is my audio doing weird things? I feel like I'm... Okay, keep going. So CQRS, the Command Query Responsibility Segregation, is actually similar to another pattern that's talked about by Martin Fowler on his Bleaky called CQS, which is Command Query Separation. And the only difference between the two is that this idea of CQRS is applied at a higher level to applications, where CQS is applied at the level of individual objects. Now, the question is, why do we want queries and commands to be segregated? What's the value in doing that? What's our motivation? The motivation from this arises from the fact that in many of our systems, though certainly not all of our systems, there are more of one than the other. There's often, in fact, an order of magnitude more reads in many systems than there are writes. So if we were to imagine, for example, some sort of massive e-commerce system, it's very likely that that system would have users browsing products orders of magnitude more than they would be someone entering product information in there, or even products being purchased. So by separating out the responsibilities in our system, this allows us to more easily meet these new requirements that we identified in the first slide. Now, in order to convince you of this a little bit, let's actually talk about the way we have traditionally built apps with a three-tier system. And certainly not every n-tier application looks like this. I have intentionally simplified things a little bit. But here we have 3 common layers in the application. And these I like to talk about as horizontal layers in an application. And we create these layers in order to separate concerns. Now, if you know me, you'll know that one of my mantras, one of my preaching points is separation of concerns. I believe that the concept of separating concerns in our software is probably one of the most crucial ideas that we can employ to build reliable, maintainable software that brings value for the long term. So I'm a fan of that, and I believe that this approach of horizontal layers in our applications is supporting that same idea. But in an application like this, we have a presentation layer that's responsible for accepting user input and rendering data back to a user. We have some business logic that's responsible for enforcing rules and so on, coordinating between components perhaps, and then some mechanism for persisting the data. Now, the difficulty with these layers is that we really can't scale these independent of one another. Sure, we can add more web servers, and we can add more database servers, but that means the system as a whole has to scale itself, as opposed to individual parts of the system being able to scale. So if we chase this fictitious e-commerce example that I have, a user browsing the site for products will really employ all these layers when they're actually performing that activity of looking for products on the site. At the same time, if a user were to come along and submit a review for a product, or to try to check out a product, it would really be using all the same layers of the application. And to complicate matters further, there are some operations that are just inherently contentious, right? So someone changing inventory of the site is going to be something that could potentially block the browsing of the site. These operations, might put locks on tables and so forth. So really what we're interested in doing is finding a natural unit of scale, that's a special term I'm going to use, that would allow us to add resources in any given layer, that would allow us to scale independently. So what I want to suggest is that we examine our applications for natural scenes. I'm not sure how well that word translates, but I mean the place where the cloth meets. And the separation in our application between what reads and what writes is a very natural scene. And we want to introduce separation along this scene that will allow us more flexibility to scale. Now, that means that we can increase the resources for just a portion of our system instead of for the entire system in order to meet the increased demand. This is also related to a concept expressed in Robert C. Barton's book, The Agile Software Development Principles, Practices, and Patterns. I highly recommend the book if you're not familiar with it. And in that book, he suggests the idea of scenes and applications as a way to support maintainability for applications, to look and see what code is changing there as a place for how you can break down your application for maintainability. I'm taking that same idea and saying we can also look for those natural scenes and applications and apply that to scalability. Okay, so I wanted to contrast the n-tier model with something that uses this idea of CQRS. So we've identified this natural division in our application between parts that read and parts that write, between queries and commands. But how can we model this, right? Notice that we really have not eliminated the horizontal layers in our application. We still have a presentation tier, we still have domain logic, we still have data persistence. But we've also introduced this idea of vertical partitions, or vertical slices in the application. We also have a common presentation tier in this example. So that might be a web server, right? The web server, though, could delegate any user input to one subsystem here that would handle changing of the state. And then anything that was reading of state could go through this system. Well, and as we've already stated, there's going to be an order of magnitude more traffic. So by dividing these two things apart, we're able to put more resources on the read side than we need to the write side. Now, these two subsystems can actually have completely different models for the way they work. One of the insights from this is that when we start separating all these parts of our application, we can really change the code in here to be optimized for what is happening on the side, and we can also change this to be optimized for what's happening on the read side. So overall, CQRS is about factoring your applications into commands and queries so you can scale components significantly. And now that you have these two different models, you can also have separate data stores, which is not a very intuitive concept necessarily. But the right side of the model, the side that handles the commands, can actually have a completely different data store from the side of the application that handles the reads. That's why when we talk about CQRS, we often talk about a second pattern called event sourcing. So now I'm going to transition to event sourcing briefly. So what is event sourcing? Event sourcing is a different way of modeling your data that fits very readily with the idea of commands. So you're probably all familiar with a traditional data model like this, a relational model. And let's continue with our fictitious example of a shopping cart. In a relational system, we would have probably two tables, one that represents the cart itself, one that represents the cart item, and there would be multiple entries in the cart item that correspond to the cart. You could also represent this in a NoSQL solution. I'm a fan of RavenDB, and I encourage you to check out the RavenDB talk later. But it still would be one object in a data store that represents the state of the object that we're interested in. So event sourcing, though, is a very different model. Instead of actually representing the entire state, instead we persist a series of events that compose or aggregate or roll up to the entire state. So in the example of the shopping cart, what I would persist actually is that a user created a cart. Then they added an item to the cart. Then they added a second item to the cart. Then they removed the item from the cart. Then some shipping information was added. Now, this is actually the way bank accounts work, right? If you look at the data stored for bank accounts, it's going to have a series of deposits and withdrawals. And if you want to understand the current state of the bank account, you really go through those and aggregate or sum up and reduce that to a current state. And that's the way event sourcing is meant to work. Now, there is a downside to this. The downside is that this is really difficult to query, right? What we expect to happen is that the events as they come in and are being persisted here, there will be some mechanism. It might be replication, it might be a message bus, or some other mechanism that actually transfers that information to a second data store that actually aggregates the stuff in real time. And that would be optimized for the query side. Now, there are, of course, inherent problems in this because there's now a delay that we're introducing between what is the source of truth, the things that actually happen, and what is being queried by the system. But there are lots of benefits too. So one benefit actually is that the data that's being stored over here can be replayed later if business rules change. So let me give a concrete example of that from a personal site that I worked on. Many years ago, there was this technology that was kind of popular called Silverlight. And I was interested in making games with Silverlight. So myself and a couple other fellows, we got together and we decided to build a site that was sort of a YouTube for Silverlight games. And we wanted users to contribute their games, and we had all sorts of achievements they could earn. They could like games, they could publish games. And we thought that the gamification, I don't know if that word translates well, but the adding achievements and badges to the site was a really good idea. But we recognized one problem that would happen is, well, what if we introduce a new achievement, but the criteria for that achievement, some user has already passed? Like maybe we say, if you log into our site 20 times, you get a badge that says, congratulations, you're a frequent member of the site. But if we don't add that rule until after people have logged in, then they've, in essence, missed it. Well, using an event source model, we were able to replay those events at the time we add the rule. So with every solution, there's a trade-off. And what is the trade-off that we would encounter with this idea of event sourcing?
And if any of you are familiar with the NoSQL movement, you probably are also familiar with the term eventual consistency. And I think that's going to come up in the Raven talk too, right? So again, see the Raven talk for more information. But one of the most noticeable problems here is that there is a delay in propagating changes from our read model to our write model. Since this process of transmitting events is asynchronous, there's this possibility of stale results when you query the read model. And this is something you need to be aware of from really a business perspective. Now, we describe this as eventual consistency because eventually the two models will be consistent. Now, in practice, though, what we find is that this really isn't as important as you might suspect. I mean, a lot of people, they see this and they think, oh, this is scary. I would never want to have that in my application. I would never want to have stale data. But really, the window of inconsistency here is generally very small. In most of the systems I've examined, it's milliseconds. In addition to that, there's many business scenarios where stale data doesn't even really matter. So if we go back to our e-commerce site, will it matter if I'm showing a product information to a user if that user doesn't see the review that you submitted a minute ago? Not really. It's not going to affect things. So it's eventual consistency is something that really from a business perspective, I think that you should consider. Now, I didn't really explain what I do at Microsoft. I do work at Microsoft, like James. So I work in a team called Patterns and Practices. And our job in P&P, in Patterns and Practices, is to produce developer guidance. So we do that by going out, talking to customers, find out what you guys are really doing, and then we go back and we try to do the same thing. And while we do it, we embed writers in our team to record, to write down, to transcribe what we're learning along the way. We wanted to explore this question of CQRS, so we decided to have a project around CQRS. And we felt that this quote embodied what we were trying to accomplish. And this is difficult for me to process in English. I'm actually curious to know if it's better in the original Greek, but I haven't bothered to learn the original Greek. So for the things that we have to learn before we can do them, we learn by doing them. So we thought the only way for us to learn CQRS was really to dive in, confess our ignorance of the topic, and to learn the way anybody would learn. So this was about 2 years ago. We decided to start this project by building an application with these patterns. We also wanted to include multiple cycles of development and release to really mirror what people are doing in the real world. And again, we decided to chronicle what we learned. And the result is not so much prescriptive guidance. It's not so much about telling you this is what you ought to do. It's rather like having the notes from a development team that recorded what worked for them and what failed for them. So we wanted to make sure that when we did this, that we were authentically connected to the CQRS community, which is a very active and lively community. We wanted to harvest as much of their experience as possible, and in a very real way, we were simply trying to map out this territory that they had already been exploring. Now, conceptually, there's a whole lot here to explore, and in many ways, this talk I'm giving you is really just the tip of the iceberg. It's only just a beginning to where we're going. CQRS community had its roots in domain-driven design, which is a huge topic by itself. And in many ways, CQRS is a continuation of the ideas that were present in domain-driven design. When we ran this project, we ran it on GitHub. It's licensed under Apache 2. Again, it was 2 years ago, and we were very excited at that point in time to be one of the first Microsoft projects that was truly open source in as much as we were accepting community contributions for both the source code that we wrote, as well as the documentation, the guidance that we were writing. And all of the results of this are freely available online. So let me skip to what did we learn? What were some of the things that we came away from this project with? First of all, when is CQS useful to you? And we actually wrote a whole book about this. I encourage you to check it out. But here's a sample of some of the questions. First of all, is there a natural seam in your application, in your system, between the reads and the writes? If there is, that means there's a possibility that CQRS could be valuable to you. Do you have business rules that are frequently changing so that you want to make a separation between the events that you're recording as hard historical fact and the rules that are being applied to them? Is scalability a challenge? And finally, are the benefits that CQRS can bring to your system clear? Because if you can't articulate the values it would bring to you, then it's probably not a good fit for it. there were some lessons that we learned along the way, too, that I think are worth repeating. And these are things that actually hurt us while we were doing this project. One thing we found was that our assumptions got in our way. And I want to encourage you to throw out your assumptions about the way you are going to architect and build apps. Try to change the way you think about them. Explore different mindsets. Explore different programming models. For example, object-oriented design is pervasive in the way we think about writing code. I encourage you to explore alternative models like functional, because it will change the way you think about software. Also, I didn't really go into it too deep, but many systems that are based on CQRS are also distributed. And what we found is that a distributed system is painful, and we want to encourage you to follow Martin Fowler's first law of distributed object design, which is don't distribute your objects. Secondly, CQRS is not a top-level architecture, and this really feeds into my other point here, which is that you need to choose the right approach for the right problem. I want to convey these concepts to you, but I don't want to encourage you to use them everywhere. Figure out where they're appropriate for you and use them in the right place. In a message-based system, which goes back to our distribution point, tracing is very, very important. I'm going to skip over that for time's sake. But one thing that's super important is this test for performance early and frequently. We made assumptions that things were going to just work well because we were using these patterns, and we found out there were some small mistakes we were making that actually really hurt performance that we should have caught earlier because we weren't testing early enough. Finally, another big point we had was that we tried to invent it all ourselves, and we suffered for it. If there are existing frameworks and libraries and infrastructures that can help, you should evaluate them. They can really be useful. I'm a big fan of open source, and I think it's amazing, really, what can be done with open source right now. So I want to have one major point here at the end. We did this project almost 2 years ago now. And I've been talking a little bit about the difference between separating out the reads and the writes. But what I also found was that there's all sorts of dimensions that you can examine your applications through to find ways to create independence in the application. And making an application or a system scalable is really about finding the ways to make individual parts of it independent from one another. As I've said before, I'm a big fan of the idea of separation of concerns. So what I'd really like to encourage you to do is to examine the systems you're building, the ones that need to scale, and figure out how you can separate concerns. I've talked about reading and writing as ways to separate, but also another really useful model is to think about logical features in your application that can be grouped together and ones that can be separated apart. And that is maybe one of the most useful ways to break apart these applications. I want to give a quick example, a quick analogy. How are we doing on time, Dennis? Are we 5 minutes? Okay. So let's take the example of a toy factory. Let's say that you have a toy factory and that a single worker in your toy factory can produce 20 toys a day. And you know that next week you're going to have to produce 200 toys a day. So there's a couple of ways to solve this problem. The obvious solution, right, is to hire 10 workers that can produce 20 toys per day and be done with it. That makes a lot of sense when we say it like that. However, the way we build our applications, the way we behave when we build our applications, is that we often try to make our workers more efficient. We try to improve their tools. We try to give them a better workplace. We try to pay them a higher salary, and we try to scale that way. That's like throwing resources in an application and hoping that it gets faster, that it gets better. When in reality, we need to design our systems so they're like individual workers that we can isolate from one another, if you will, that can be independent from one another, and then we can scale by simply hiring more workers. There's a whole lot baked into that topic that I'm not going to have time to go into, but I encourage you to maybe check out the deck afterwards and feel free to ask me questions about that. So my major idea is that scalability results from putting independence in our system, from separating out concerns in our system. Here are some links about the project that we ran at Microsoft. The code is all available on GitHub. We also have the same documentation is published on MSDN here. We have a PDF of the book, and I'm very excited to say that in April of this year, we'll be releasing the book translated into Russian. So we were hoping to get it done before the conference, but ran out of time. So we're very excited about that. Also, feel free to harass me on Twitter as well. Questions?
I wanted to ask about eventual consistency.
Yes.
It can be viewed as temporal inconsistency, right? For some time, your system is inconsistent. So the question is it possible that we have a permanent inconsistency situation because of you've committed your event to the event sourcing, but didn't notify your read model of that? The message got lost or something.
Right. So to restate that question, is there a possibility for permanent inconsistency because of some failure in your system? And I would say yes, that's true. But that's also true with traditional applications, right? We can corrupt data easily in a relational store by having bad business logic, right? It's not a fault of the persistent store, it's just a fault of our application logic. So I think there is possibilities for that, but one of the nice things about using event sourcing as a model is that if there is inconsistency there, you can actually throw away the read data and rebuild it. So that is a common solution to it. And again, I sort of rushed the talk because of our time being rushed, but one of the things I failed to say is that I'm not encouraging every application or every part of every application to use that same model. You might have a system that uses simple two-tier CRUD writing straight to a database for one part of the for one subsystem, and another part that uses CQRS.
Hello. CQRS always usually goes with event sourcing.
Yes.
Other situations, solutions, when CQRS is better without event sourcing and when we should not use event sourcing.
Okay. So to restate the question, it's when CQRS and event sourcing often go together, when is it appropriate to use them together, and when is it appropriate to use them apart? So event sourcing really brings its own set of complexities to the problem space. And I think the way to really address that question is first to ask, does event sourcing add any value to the business problem I'm addressing? And if you can't answer yes, then I wouldn't use it because it adds complexity. In the guidance, we actually talk about some scenarios where we use CQRS with event sourcing and without. I don't have a concrete example to give you, but the answer is yes, you absolutely can use CQRS without event sourcing. It's just you would use a more traditional data store under the covers for that.
My question is about responsibility. I'm not sure, from your slides, I'm not realized who is responsible to transfer the events from the read to write model. Is the write part is responsible to transfer to read model, or its read model will pull the data from the write?
So the question is, who's responsible for transmitting information from the write side to the read side? That really depends on the system. I mean, so this is the joke I have is that the consultant's answer to every question is, it depends, right? And that's true again here. It really depends on the system. That could be actually an entirely different part of the application. It's like some sort of message bus infrastructure that's responsible for just taking messages that originate on the right side and moving along. So if we had some specific scenarios, I might be able to give a more specific answer. But again, I think that really depends on the system you're building.
Hello. Getting back to the CQRS model, you've said that it consists of two vertical slices totally separated from each other. But what about cross dependencies? For example, if your command handlers depends on the accumulated states
of something else.
It's kind of broke all the beauty of the model.
Yeah. So the question is really, what happens when you can't separate these things out cleanly? So part of the analysis that I skipped over here is learning how to separate your applications into something called bounded contexts, which I don't like that word because no one really knows what it means. But it's a logical grouping of features in the application. So the first step in applying something like CQRS is to really analyze your application from a feature perspective and to understand what things group together, to look for places where there's natural divisions in the application that will limit those dependencies. Now, there's also situations when you still will have some sort of dependencies, and there's some mechanisms for providing some coordination across parts. And actually, we addressed some of that in the guidance that we wrote.
Hello. The question is kind of a continuation to the previous one. I feel like there is one place when we always need coordination between update and read. When user submits a command and then it expects to see an updated UI immediately. But if we have different models for update and read, how do we solve this?
So the problem is when you have two different models, how do you have immediate response going back to the user? And actually in our reference application, we actually have that exact problem and we address it. So there's a couple of different ways to do that. One way might be that your presentation layer, so remember the one slide I had a common presentation layer across the top. It may be that the right model has some temporary cache of what it just did that it can respond back to the user with. Because a lot of times, like the example we wrote was a conference management system. So for people planning events like CodeFest, right? People wanted to register on the application and then know their registration was confirmed. In that situation, we really had everything we needed to show the user from the command that was sent back. All we really had to say was, yes, this command was received. So often there's information that's present on the right side that you can just use to immediately respond to the user. But again, partially that all depends on context. There's some other tricks to apply where you might actually have the right side, when something is successful, that it would send messages back that can be surfaced in the UI. Much harder to do in websites though than it is to do that with like GUI applications.
Hi, Christopher. I have the following question. Assume we have, am I right assuming that read model and write model should be separated in CQRS?
So I didn't follow the whole question.
Well, if we don't follow the CQRS pattern, we need to common model that manages reads and writes. But in CQRS, we have to separate them.
So is the question is, if you need them together, why would you take them apart? Is that?
В общем, когда у нас две разные модели, мне кажется, возникает большое дублирование между ними. Это правильно? Да.
Oh, okay.
And this is a violation of don't repeat yourself.
So, okay.
Principle.
So, by the way, I did understand the word когда in there. When, right? So, okay, so the question is, don't you end up repeating yourself when you have these two separate models? So, you can end up repeating yourself. And I think this is actually a really interesting question that I've been thinking about a lot lately, because for a long time I've been a fan of don't repeat yourself, and I still am. But I think there's actually sometimes a danger in overusing the same code. So let me say this. This may be a little bit off topic of your answer, but I'm going to use it. It's possible to have two pieces of code that look very similar in an application, but that mean different things, that have a different semantic purpose in your application. And I would actually argue that combining those two is an anti-pattern, because you would end up in a situation where now you have two things that look similar combined together with different business requirements in the future, trying to pull them apart, but creating complexity inside that part of the application. So I think there are some times when you might end up with duplication, but I think that's a problem you have to judge and weigh to decide if you're going to get value from it. And if you're not going to get value from it, if it's going to make it harder to maintain, then I would discourage you from doing it. Because at the end of the day, one of the things I'm most concerned with is maintainable code. So I know that's a soft answer, perhaps.
Итак, это был последний вопрос. Друзья, спасибо.